Hello everyone, my name is Dan from the Rensselaer Polytechnic Institute Engineering Ambassadors, and this is the first video in our online video series called 3D Printing and Engineering Design. This video series is split into 3 different modules, and today is the first module where we'll give an introduction to 3D printing and specifically talk about the printers in RPI's Forge. The Forge at RPI is a new makerspace that allows students and the RPI community to collaborate and print designs. Now, we want you to be able to take advantage of the Forge as well. The next modules incorporate different engineering topics and 3D printing into engineering design challenges, so you will actually design and print something to solve a problem. Today, we'll talk about the basics of 3D printing and go over the process from a design to a finished product. Next, we'll talk about the different types of printers in the Forge and the advantages of each. Finally, we'll give a quick introduction to CAD using Tinkercad and let you start designing. 3D printing is also known as additive manufacturing, and it was developed in the 1980s, but really only became popular until relatively recently. Just like you can print 2D images quickly from your computer, 3D printers allow you to print 3D objects quickly from your computer. The only limitations to what you can build with 3D printers are the size and resolution of your printer and what you can design on your computer. People have printed phone cases, game pieces, guitar bodies, bike helmets, nuts and bolts, shoes, and even cars. The first step to printing any object is to design it in a CAD program. CAD stands for Computer-Aided Design, and there are many types of CAD programs that you can use to design your object. Today, we're going to use a web-based CAD program called Tinkercad to start designing objects. In the past, engineers had to draw up their designs by hand. This was a time-consuming process, and there was a lot of room for error. Also, if you weren't good at drawing, it might be difficult to design detailed parts. Now, CAD programs such as the one shown on the screen here make the design process much faster and allow for more accurate parts. However, a CAD file cannot be sent directly to a 3D printer to print because the printer will not be able to understand the information the CAD file is giving it. To convert your CAD design into something the printer can understand, it must first be saved as an STL file. STL stands for stereolithography, which is different than the stereolithography form of 3D printing that we will talk about later. STL can also stand for Standard Triangle Language and Surface Tessellation Language, but these are not the official meanings. An STL file describes the geometry of a part in a CAD file by converting the surface into a system of triangles, and it does not describe the color or the texture of a part. Now that we have a version of the file the printer can understand, we can move on to the next step. Now, the STL file needs to be loaded into the software program of whichever printer you're using. If you're using one of the MakerBot printers, you must open the STL file in MakerBot Desktop or MakerBot Print. If you are using one of the Lowesbot printers, you need to open the STL file in Cura. Finally, if you're using the Formlabs printer, you must open the STL file in Preform. Although they all have different names, each program has a similar layout and features. All of the programs have a darkened surface that represents the size of the build platform your object will be printed on, and the 3D wire box represents the maximum size of the object you can print on that printer. In addition, each program has functions to move and rotate an object, as well as to select supports, rafts, and the infill percentage, which is what percentage of the interior of the object is completely filled with material. If the infill percentage is 0, then the object will be hollow, and if it is 100, then the object will be completely solid. Once your object has been loaded into the printer's software program and the settings have been updated, you are ready to print. STL files don't store color information, so the only way to print an object in color is to choose a printing material with the color you want. There are many different materials and colors available for printing, so you can print in really any color you want. The possibilities of making objects using 3D printing are endless. Although that process may have seemed complicated, it's really not. 3D printing is a method of manufacturing objects with little preparation needed. Additionally, 3D printing has many other benefits. One of these benefits is that 3D printing has less waste than other types of manufacturing. Conventional manufacturing is normally a subtractive process. You start with a block of material and cut off parts you don't need to get the finished product. This produces a lot of waste. On the other hand, 3D printing is what is known as an additive manufacturing process. Parts are built from nothing by adding material. Because nothing is being cut off, 3D printing produces a lot less waste. Another benefit of 3D printing is that it allows you to build a rapid prototype of your design. Conventional manufacturing processes can require a lot of time to build a part. If you get the part back and something is not right, you'd have to send it back and wait all that time again to get the fixed part back. With 3D printing, you can print the part in a few hours, test it to see if the design worked, and then print an updated part if necessary. This could be done within a day, whereas it might take a week to do this with a conventional manufacturing process. One final benefit of 3D printing is that many different printing materials are available. If you need a material with high impact strength and high toughness, or a material that is biodegradable, you can find it. The printers in RPI's Forge only print plastic materials, but 3D printers that print metal and ceramics are also available. There are many different forms of 3D printing, but the two forms the printers in the Forge used are fused deposition modeling, or FDM, and stereolithography, or SLA. This stereolithography is not to be confused with the stereolithography that STL stands for. They are two completely different things. FDM and SLA are very different, so I'm going to go over the differences with you now. FDM is the form of 3D printing you probably think of when you think of 3D printing. This video will show you exactly how objects are made using the FDM method. As you can see in the video, in FDM, objects are made layer by layer. That little nozzle moving around the part is where the material is coming out of, and it's sending heated plastic to the correct position with computer-controlled precision. The disk of material at the bottom of the part is called a raft, and it is not part of the object, it just helps the object stick to the building platform during the printing process. Stereolithography is the other form of 3D printing used in the Forge, and this form is much different than FDM. This video will show you how objects are built using the SLA printing method. In SLA, the printing material, resin, is poured into a tray at the bottom of the printer, and the build plate is lowered into the resin. The build plate slowly raises out of the resin as an ultraviolet laser is shined into the resin to harden it into the correct shape. After the part is complete, the part has to be washed in a bath of rubbing alcohol to wash any remaining resin off. As you may have guessed by watching those videos, FDM and SLA use very different materials. FDM uses spools of plastic in wire form that look like the spools shown in the image on the left. The wire is heated and sent through an extruder during the printing process. Many different plastics can be used, including ABS, which is what Legos are made out of, and PLA. As we saw in the last video, SLA uses a resin that comes in liquid form that has to be hardened using the UV laser. Both of these materials come in many different colors. After an object finishes printing, some work still needs to be done before it is complete, and this work is called the post-processing procedure. FDM and SLA have different post-processing procedures. In FDM, supports are sometimes used to ensure an overhanging part of the object does not fall off during printing. These and any rafts need to be removed from the part. In addition to the removal of supports, SLA parts also have to be cured in UV light to completely harden them. There are some drawbacks to FDM and SLA. Objects in FDM are printed layer by layer, so it is possible to see these layers on your object after it is finished printing. This might be a problem if you need a very detailed object. Additionally, the tops and bottoms of FDM parts might have worse surface quality than the sides. SLA objects are generally more detailed and accurate than FDM objects, but the post-processing procedure is much more involved and longer. There are usually many more supports on SLA objects than on FDM objects. Additionally, SLA objects have a smaller maximum size than FDM objects. CAD isn't the only way to get a 3D model of an object. You can also use 3D scanning. In this process, many pictures are taken of the object you want a model of and uploaded to a computer to generate a 3D model. No design work has to be done by the user. You just need pictures of the object you are trying to scan. However, you can't use any old object in 3D scanning. Complex geometry, reflective objects, objects with complex internal structure, and transparent objects cannot be scanned. Now we're going to talk about the 3D printers that the Forge has. The Forge owns 6 printers, 4 full-size printers and 2 mini printers. The MakerBot Replicator Z18 is the largest, and then we have the Lulzbot TAS5 and the Lulzbot TAS4, and then the Formlabs Form 1 Plus. Finally, we have the Lulzbot mini printer and the MakerBot mini printer. Each of these is a little different, so we'll go through each individually. The MakerBot Replicator Z18 is an FDM printer, and it has a very high surface resolution. In the Forge, we use the Z18 to print PLA objects, but it can also print ABS plastic. This printer uses the MakerBot desktop software. This printer can also print the largest objects, as its maximum height is 18 inches. The Lulzbot TAS4 and TAS5 also use the FDM printing method, but their resolution is not as good as the resolution of the Z18. The Lulzbot printers use ABS plastic, and the software program they use is Cura. The Lulzbot can print medium-sized objects. The Formlabs Form 1 Plus uses the SLA printing method, and because of this, it has a seamless surface finish and is the printer that can create the most detailed objects. As we talked about before, the Form 1 Plus uses resin, and it uses the preform software. The Form 1 Plus can print small-size objects. You don't have to be an engineer to 3D print. Anyone who has access to a computer and a printer can create anything they can imagine. Sites like Thingiverse allow people to post their designs online to download, so you can even print objects that other people have made. 3D printing allows you to be creative and make objects you could never have built before. Now we will move into an introduction to CAD using the program Tinkercad. Tinkercad is a free online CAD software. I'm going to go through a quick tutorial, and then you'll be able to make some designs and get used to how everything works.